Well, ladies and gentlemen, we had two engineers who were speaking just before me. I don't claim to be an engineer. I'm a management student and a management teacher. And by default, have become an education administrator. Having established the IIM at Indore, and then subsequently headed the Narsee Monjee Institute of Management Studies, which is today a deemed university for the last two terms that I'm now going to be completing it. So what I'm going to be speaking today, right now, and what I would like to talk about is more out of my understanding of where education is really headed to and what kind of changes need to be brought about. But more specifically, in the engineering education, especially from the experience that we have had in the university ever since I took over as the Vice Chancellor with our Mukesh Patel School of Technology Management and Engineering, which was established in 2007, and today is considered to be one of the premier engineering schools in the city of Mumbai, from whatever is the kind of parameters that one would want to put it across. If I were to go back in time, and if I were to think in terms of what is it that have been the kind of three factors that have really been the motivators and which have been the drivers of the change at MIMS, and where we see the university today, not only what internally, but also externally, the whole society sees it today as being a very different kind of an institution there. I think there are three kinds of factors that have really contributed in a very big way of making NMIMS today one of the premier institutions in this country. One has been the relevance, one of the biggest kind of a challenge that I always had, and the challenge that I would often talk to my own colleagues in the system in 2009 when I took over, was that how do we remain relevant? The question was of relevance to the industry, relevance to the society. That was the biggest kind of a concern. And believe you me, it is not something which was so easy for us. Because ultimately, at the end of the day, we were talking to people who had a fixed mindset, people who had really studied something, what Mr. Punya was saying. One would have studied engineering back in 1970s, and then as the dean of the engineering school, well, he had a fixed ideas. He had looked at Bombay University. He had all the kind of things that he knew of. But was that person really relevant to the times, the way things were changing? The second one was very clearly the quality. But the quality was not just merely in terms of getting some kind of a stamp of approval of an ISO or an accreditation agency. But the quality in terms of the process, quality in terms of looking at what kind of students we are getting, looking at what kind of processes we were putting in place. And apart from that, there was a leadership issue that we talked about, and finally we were talking about in terms of the fact that are we really developing students who are going to be employable? Those were the kind of four parameters that were there. Now when I looked around engineering education, and extensively we have all talked about it, one of the biggest challenges that has always existed for us has been that of the employability of the students, the engineering graduates. It's now a known fact, and not too very secret a fact, that the employability of the students in the engineering system is no more than 10% of the students who are graduating today. If the system is admitting 100,000 students, no more than about 1,000 students are getting placed, or maybe maybe at best another about 1,000 getting placed. So where have we really missed out? What is it that has really happened? And very amply brought about by Mr. Agarwal, that if, for example, we continue to teach something which we had known earlier, then I think we have a problem there. But more specifically, to my mind, was a very big change that happened back in 1990s, and especially in the late 1990s and early 2000, when in order to overcome the shortage of engineering teachers in this country, because the capacity was getting expanded, AICTE decided and AICTE permitted engineering schools to hire the B.Tech as the teachers back in engineering colleges. So what had happened, typically, somebody who just graduated today, the other day, he was on the side of the teacher. He was teaching. And why? Because so far as the engineering college was concerned, that was perhaps the cheapest. From the point of view of the student, it was perhaps the best option because there was no other employment available to him. So this person who got the job knew only what was taught to him. So typically, it was a GIGO in management terminology. Garbage in is equal to garbage out. So if in the mental process, if the person has not experienced industry, if a chemical engineer has not experienced the chemical firm, if a mechanical engineer has not gone to the shop floor and has worked on a forging machine, as an example, or an automobile engineer has not gone to an automobile plant and has really understood the paint shop, as an example, then I think he's not really the one that can really teach the automobile engineering or mechanical engineering or a chemical engineering. But that was the kind of a scenario that we had. And it was no different for us at Mukesh Patel. So we said that, look, this has got to change. If in management education, and again in the management education, the same problem was happening. An MBA would teach an MBA. And I said that, look, that is fundamentally a wrong kind of a perspective. So gradually at LMIMS, we started changing the entire complexion of the teachers. So we said that, look, we got to change this whole equation of a graduate engineer teaching a graduate class, or a graduate management student coming in and teaching a management program. The person has to go into the industry, has to come back with an experience, has to have some kind of a research before he really gets into the class. Now, obviously, I couldn't have changed everybody. I couldn't have transformed the whole institution, or we couldn't have really done anything over there unless and until we start developing our own people. And which is where we said, fair enough, I'm going to be sending the people over to the industry. So as an institution, we took a decision. We said, from now onwards, our faculty is going to be spending, just like the students, a summer term in the industry, work on live problem, come back, and then start working along with us. There was a kind of a change that we started seeing. So the employability, when we are talking about it, I think the employability aspect, if we have to tackle, I think the first thing have to be in terms of seeing, are we really building up the skills that the industry is really needing? And employability is not only from a placement perspective. This is something which is so fundamentally a wrong kind of a proposition. Employability is whether the person is able to create a meaningful work. Are we able to create a meaningful, is the individual meaningfully employed? Or is the person a meaningful economic actor? That is, to me, the fundamental part. And which is where the entrepreneurial aspect comes in. So the entrepreneurship, the placement part, those are the two fundamental skill sets that we were talking about. The third one was very simple, that the fact was that our curriculum was obsolete. We were talking about something which Dr. Agarwal was just mentioning about it. Our examination, I was talked to my controller of examination, and the controller of examination would tell me, sir, we cannot sort of certify unless and until the person has written an exam. I said, that is ridiculous. How do you evaluate work? What kind of a credit are you going to be giving to the work that the student is going to be doing? If the student is making drone, for example, am I giving some kind of a credit to that work that the person is really doing or not? If that is not what the system is doing, then I think there is fundamental error in the whole system itself. So therefore, to me, work was very critical. So we said we need to give a credit to the work itself. And clearly, in terms of the curriculum, we said we need to sit back with the industry, we need to sit back with the society and understand what is it that the society was wanting and what is it that the industry was wanting. But that is not all, because I'm a firm believer as a marketing professor that the customer does not know everything. But what is important is to understand the customer situation. What is important is to understand the customer's problem. And if you understand the context, if you are able to understand what is happening around in the customer environment, as a firm, as a marketing graduate, you will be able to come out with solutions which are going to be workable in a customer situation. Coming back into the engineering, again, I look at it. Perhaps in the engineering curriculum design, it isn't just merely important to just sit down with the industry, but to really understand what is happening in the industry. What is the kind of an environment in which the industry is operating? What are the global developments? How are the markets changing for this particular firm's products and processes? And is there a way by which I can create a solution over there? And that's where, the development aspect comes about. Nobody else can really create such a kind of a wonderful development other than the engineer. And engineers are also, incidentally, one of the best managers that I can think about it, though I'm not an engineer by training and education. And why do I say that? For a very simple reason, that the change that we are witnessing today, the magnitude of that is almost 10x. Take a look at it. What we were doing until yesterday, we are not doing it today. And what we are doing today, certainly we will not be doing it tomorrow. So as a consequence of this magnitude, this change, the fact is today, and obviously technology is the key driver in this change, what has happened, clearly what we realize is that this technology today has become is today impacting individuals' life. You and I are affected by this technology. Even though we may not be technology savvy, but each one of us is a user of technology. And the moment I become the user of technology, I start understanding what this product is really all about. When I start understanding what this product is all about, I then start saying, what if there is something else to it? So therefore, I as a customer, I as an individual, now start talking about a lot of things that I was not talking about it. The social structures are changing. And clearly the economic development models today are greatly impacted by technology. The fact is that today, the industry that we are talking about is a knowledge industry. And it isn't just a computer-based industry. It isn't just merely a machine-based kind of a change that we are talking about. We are talking about a knowledge where data is supreme. Data exists. Data today is there in multiple kind of forms available to us. But the question is simple. Am I able to take a decision based on this data? Do I really take a kind of a call? And have I been able to really understand how this data is going to help me take a call on a particular situation? So the market is today, industry today is a knowledge-based industry. It's a data-driven kind of an industry. It's an industry which is connected. Every firm, every machine, every individual is today connected thanks to IoT. And certainly it is a far more global itself. Today we are talking about smart factories. What has that smart factories really done? We find that these are the factories that are operating with much lesser workforce, but they are intelligent machines. These are machines who are capable enough to produce. Only thing is that the person who really designs, the person who feeds the data, must know what has to be fed. As long as I know what has to be fed, the machine produces it. And the machine doesn't just merely produce it, the fact is that the machine talks to each other. That's where the power of the IoT comes in. And it isn't just merely the power of the IoT that comes in, but the fact of the matter is that today, with this IoT and with this kind of a connectivity, the firms develop what is called as an integrative view of operations. Now look at back in engineering colleges what we are doing. We are teaching engineering, or we are teaching any education in a silo. We keep talking about it in a silo. And thinking that this silo is really the 100%, this silo is the whole. The fact is that silo is not the whole. My hand is just one hand, but together, both the hands, my eyes, my ears, my limbs, every part of it makes my body. Now the pattern today, ability to create a pattern which is understood by the customer in the manner in which I understand it, that is important. So therefore, from that kind of a perspective, clearly what I believe, and today that is really possible, there has to be a very different approach to education per se. Technology has the capability to create solutions for human society, for the human beings. And therefore, to my mind, the education, technology education, engineering education has to consider the human being, has to consider the society, has to consider the human processes. If you are able to understand that, then in that case, you are able to create an education model which is flexible, interdisciplinary, and certainly the one that provides an understanding of the human processes. It is integrative. You've got to create an integrative kind of a program. You cannot continue to teach let's say, a chemical engineering plant, not really knowing, chemical engineer not knowing what's happening around in the computers itself. The global orientation, and certainly a pedagogy to encourage what I call it as experiencing the phenomena. Classroom alone is not enough. You've got to take the student right there in the field. The field projects have got to become a far more integral part. If a civil engineer does not know, for example, how the road is made, if he doesn't understand the element of material science, if he doesn't really understand the strength of material by doing an actual test on, let's say, a construction site, then to my mind, that engineer is not worth the same. And clearly, I'm just taking a minute more. So quite clearly what we are saying, therefore, is that the pedagogy that we are talking about has to encourage the experiencing and provide the design experience to the students. Get the student, give them the time to design a product, to design a solution. Wonderfully, Dr. Agarwal gave an example of an institution where the students had created a network, had sort of connected all these institutions in the campus itself. Unless and until that design experience is really provided and the students are able to experience the entire program or experience the situation, I think we will be creating engineers of no worth itself. So clearly we are talking about an integration. Quite obviously, at the end of the day, what we are saying in all this, it is the cognitive skills that you need to develop. You need to create the cognitive skill, the mental processing. It is your ability to create that kind of a comprehension of the problem. The student should be able to comprehend the problem. The student should be able to understand the relationships of the various parameters of that problem with the finality itself, the execution, complex problem solving. And clearly we are talking about diversity management, design and leadership and critical skills. In all this process, quite clearly, industry and community has to partner with the institution. No development can take place unless and until you partner with the industry and the community. Remember, at the end of the day, the world is only going to be dominated by two people. One, an entrepreneur, and the other, an innovator. Because only these two people will have the power to create the change. Ladies and gentlemen, thank you very much.